Welcome everyone. This is Google Developer Student Clubs of Jalpaiguri Government Engineering College presenting to you the session on cloud, that is, exploring the realms of cloud computing. We are very privileged to have among us our guest speaker, Mr. Anubhav Singh. He is the Google Cloud expert in GCP, as well as the Google Summer of Code contributor in the year of 2019. I would like to hand over the session to Mr. Anubhav Singh, and he would be enlightening us on the topic of cloud computing.
Cool. Hi, everyone. Glad to be here. Thank you for the short introduction. Uh, yeah, there will be more of my introduction later. Let me quickly share my screen. Um, yep. And yeah, so while it says it's introduction to Google Cloud, please do not worry. I'm not going to make it all about Google Cloud. We'll have an introduction to cloud itself. And at the same time, I'll also show you how to quickly build stuff. And towards the end of this session, we will also discuss about career options in Google Cloud, or let's just say in cloud technology in general. And yeah, we'll also look at like how you can, make your resume come out better to apply for cloud related jobs. Not specifically just in cloud. You could be someone who is exploring things like, say, Android development or maybe web development or anything which is using cloud in any manner. You might be interested in getting, a role with cloud domain. I'll talk about that. Let's get started very quickly. So, hi everyone. This is Anubhav Singh, co-founder Dynopii, Google developer expert in Google Cloud, and a bunch of other things. If you are interested in knowing anything about any of these, do let me know. And let us get started, right? So, why the topic? Why are we going to talk about Google Cloud today? Or let's just say, in general, why are we going to talk about cloud, right? Why do we need to learn cloud? Because this is a very recent research which told us that in the coming 5 years there will be a boom of jobs related to cloud computing, not just purely in cloud computing, jobs related to cloud computing, right? As operations, as backends are moving to cloud, as a lot of things are moving to cloud, people are using cloud for faster startups, faster building iterations, and stuff like that. And that is why it will create a lot of jobs in the coming few years. It has already been creating a lot of jobs in the last couple of years, if you have noticed, especially accelerated by the COVID-19 pandemic, when the world went, you know, working from home. Cloud computing was on a boom, right? And it has continued since then, and it will keep on happening for the upcoming few years, which I can see. And at the same time, for those of you who want a simpler reason, it's because the problems that we are solving today have changed. They're not the same that we were solving 10, 15 years back when internet was new, when putting up a website was enough, right? So if you remember how Amazon started selling books, initially they just had a website on which books were listed, and people would place orders by calling on a phone, and then they would confirm their order and deliver it. But today we don't need that, right? Today what we want is we should be able to see the whole catalog, purchase things, pay online. If anything fails, we should get the refunds. If we want to cancel it, we should be able to cancel the order as well. And all these things are being done online, and this requires a lot of computation power, right? And that is why the problems that we have been solving, the problems have changed, and that is why the tools required to solve these problems need to change at the same time, right? And yeah, let's see the agenda for today for the next 1 hour, hopefully. I have a bad habit of overshooting time on online sessions. So if I'm running out of time, Shreya, do let me know. But yes, this is the simple agenda that we are going to try to follow. At the same time, something that is missing on the agenda is overview of cloud technology, which I will cover just before covering overview of Google Cloud, right? So before I jump into Google Cloud, let me talk to you about what is cloud. And to be able to do so, I need to understand very quickly what is your understanding of cloud so far. So here's the question. The question is, what do you understand by cloud technology, right? Just go ahead and start typing your answer in the chat box.
You're
You
able
should be
to
able to,
type,
yeah.
right? I'm not sure completely. Can anyone type and confirm whether you are able or not?
Yes, you should try typing.
Yes, they are.
Perfect. Yeah. Please go ahead and type in what do you understand by Google Cloud. You don't have to search for this. You don't have to pick up the right answer from the internet. I just want to know what you understand from it. Right? Just go ahead and let me know what you understand from cloud technology. If you do not know what cloud technology is, please feel free to write that so that I can understand how many of you are new to this. Okay? Give me very quick answers. Also, this session is going to be very interactive. I'll ask a lot of questions, so you should always be prepared to type in answers. Okay? So, cool. I'll just wait for a few seconds for some of you to write the answers. Storing and managing data online. Okay, this is definitely one of the things. Google Cloud is like an online platform for resource management. Okay, okay. No knowledge about this. That is also fine. That is why you are in this session, right? Because you want to learn about it. So that is good. Google Cloud is a storage, new achievement, and managing our business also. Okay, so you understand it is about storage. Very interesting. I'm not specifically asking what Google Cloud do, right? I just want your basic understanding of cloud technology. Don't worry about Google Cloud for now. Just think about cloud technology in general. If you have used cloud at any point of time, let me know in which manner you used it, right? How did you use cloud if you have used it anytime? A server for data storage. Okay, very interesting. Okay, a lot of you are talking about storage, and one of you mentioned resources. What else can you tell me about cloud? Have you used cloud at any point of time? By any chance, have you used anything on cloud or used cloud for doing anything? Data storage, yes, you're right. Data storage mostly. A lot of people's introduction to cloud is actually through data storage, but that is what even our parents do, and people who are not in tech, even they do that. So, being people in tech, we should know more about cloud than just storage, right? And that is what I'll try to attempt today, so that you can learn what it is. Cool. At this point, let me start sharing, a different tab because this is something which I did not prepare in presentation. I wanted to explain this to you firsthand. And at any point of time, if you have a doubt, put in your question on the chat. Okay. So let me try explaining what cloud technology is. So let me get started with let's say let's say this is your laptop, right? Your laptop. As simple as that, right? This is your laptop. And what does your laptop have in terms of resources, right? This is one term that we are going to use. We are going to use the term resources, right? Let me write that term down here. We are going to talk about resources, okay? Let me try to make this slightly bigger, right? This is the term that we are going to talk about a lot. What does resources mean? If any of you know the answer to what resources means in terms of your laptop, do write it in the chat. Otherwise, I'm going to explain right now. Okay. So there are a couple of things which can be called resources on your laptop, but the most important things which can be called resources are computational power, right? The first most important thing is computational power. And then the other thing which is important is storage, as many of you pointed out, that cloud is used for storage. And uh, if you wanted, you could also additionally maybe add, uh, let's say, memory access, right? Memory access, right? Although memory access is more about a combination of computational power and storage, and it is a kind of computational power, right? So by memory access, I basically mean access to RAM. By computational power, I mean CPU. And by storage, I mean the hard disk drive or SSD or whatever you have in your laptop, right? So for now, to simplify things, I'll remove memory access. I'll change computational power to compute, and storage I'll let it remain as storage, right? So compute and storage, let me increase the font a bit. Let's say 24 is good, right? 24 is good. Yes. And even this I can increase to say, yeah, let's keep it at 36. Yeah. Okay. So here's the thing, right? Your laptop has mainly two things, compute and storage, right? Compute, as I said, it is the access to your CPU, right? Your CPU performs the operations, it churns data, it performs calculations and things like those, right? And then storage. Now, say your laptop has how much compute? How much RAM does your laptop have? Let's say 8 GB of compute, right? I think a lot of you might have laptops of 8 GB, or some of you might have 4 GB, some of you might have higher 16, 32, or things like that. Let's just take an average. 8 GB is very popular in today's date, so let's move ahead with 8 GB of compute. Storage, let's say you have 500 GB of storage on your laptop, right? So this is a very standard laptop in today's date. 500 GB of storage, 8 GB of compute, right? And there might be some other devices. There might be a keyboard, there might be a mouse, there might be you might have connected pen drives and stuff like that. Let's just remove those. Let's just focus on compute and storage, CPU and hard disk, right? That is what we are going to focus on. So let me remove this part. Let me give a name to your laptop. Let me name it uh, say master, right? Or let me say master machine, right? So this is what your laptop will be called now, master machine, right? Let's say in the same room there you have a friend, right? Friend's laptop, and your friend's laptop similarly has these two features, right? Your friend's laptop again has these two features. Let's say your friend has just 4 GB of compute power and their storage is just 100 GB, right? Now, what your friend wants to do is your friend wants to perform an operation which requires higher amount of computational power, right? So your friend has two options. Your friend could ideally, which is the most general case, do it on his own laptop, right? Say, for example, he wants to render a movie, right? The movie rendering will take more time, obviously, on a 4 GB compute laptop, right? If a laptop has just 4 GB of compute power, it's just going to take more time compared to a machine with 8 GB of compute, right? As simple as that. If any of you have any doubt at any point, just put it in the chat, right? I'll make sure to clear it up. Cool. Let's proceed with this, right? So 4 GB of compute this person has, your friend, and he wants to render a movie which is very computationally intensive. So he has one option. He can ideally do it on his own laptop, or else what he can do, he can uh, he can transfer the resources to your laptop, right? He can transfer the resources to your laptop and he can run an instruction to your laptop via a network connection. Maybe you are on the same Wi-Fi. Maybe you are connected via physical wires. Does not matter. So your friend, what he does, he sends the raw files to your laptop, which is the master machine. He sends it here and he says that render this video, right? So this is what he says. This is the raw file. This is the processing script. Render it. And when the rendering is done, then it is returned, right? Then it is returned. So this is what happens, right? Your friend's laptop, he uses the computation power on your machine by connecting it through any sort of network, right? It could be Wi-Fi, it could be via direct connection of LAN wires, right? It could be by sending you an email. Does not matter how they are connected. Does not matter. What matters is that your friend used the computation power on your machine to do the same task which he could have done on his laptop, but at a slower pace, right? Now let us make this more interesting. Let's say instead of your master machine, let me say you buy some new laptops, right? What you did was you bought some new laptops, and what you did was you created uh, worker machines, right? What you did was you created worker machines. And what these worker machines are, they are basically other laptops, right? You bought three more laptops and you named them worker machines. And this is worker machine one, this is worker machine two, and this is worker machine 3, right? This happened. Now, what your master machine can do, your master machine can delegate tasks to worker machines, right? So, you, oops, this line is not looking good. Yeah. Okay, yes, I got it now. Cool. So what you did, you bought three other laptops and you connected them all to the master machine, right? Let me change this a bit. Okay, yeah, this looks good. So you bought three other machines and you connected them to your machine, right? Now what your friend can do, your friend can actually ask for three video renderings at the same time, right? If your friend sends you three videos to render, you can do it very easily because what your friend did, your friend sent you the video files to your master machine. And from here, you sent it to worker machine 1, 2, and 3. So worker machine 1, 2, and 3 are actually doing the job. After doing the job, they are returning it back to master machine. And then from master machine, you are sending it back to your friend's laptop, right? This this whole paradigm, right? What I've shown here, this is called distributed computing, right? This is called distributed computing. Now, cloud computing is actually an extension of distributed computing itself, in which you are not connected via LAN, you are not connected on the same Wi Fi. Rather, your connection is actually internet, right? So if your connection is internet, and sometimes internet, right? Sometimes it's internet, but most of the times the general norm is that it's internet, right? So if your connection is on over the internet, then you are using a cloud, right? So what I could do, I could actually change this name. I could change it to say Google Cloud Platform, right? So I could change the name to Google Cloud Platform, and I could give you what would I give you to use this? I would give you an interface. Whoop, please don't go that side. Let me shorten it to GCP and let me move it to the left. And what I would do is I will give you an interface GCP website, right? So what you essentially do from your friend's laptop, or let's say it's no longer your friend's laptop, now it is your laptop, right? Say, for example, now using your laptop, you could connect to GCP, and GCP has a lot of servers on the backend, which it uses for doing the computations, right? Now, here's the interesting thing. If at this point you asked me, if I have a file of, say, 800 GB, right? Your problem is that you have a file of 800 GB. Can this be stored? Right? This is the question. Can this be stored? Stored. How will it be stored? How will you see that it is being stored? Right? So, okay, you said no, right? In distributed computing, this is actually a no, right? Because distributed computing is not about distributed storage as well. There are obviously paradigms in which you have distributed storage as well. But in this particular case, you have distributed computing. You cannot pool the resources together, right? It is not a virtual pooling. It is rather you take a computational task, you distribute it, you cut it down, and you send parts of it for computation. This is what distributed computing does. Now, in case of cloud computing, we come towards something called virtualization, right? So what this VM will do, it will create, whoops, yeah, this VM will create something called virtual machines, right? It will create virtual machines. So what will these VMs look like? VM1, you asked for storing 800 GB file. So let's say you want 1 TB of storage, right? 1 TB storage. And since file storage really isn't computationally expensive, let's say 4 GB of RAM, right? But this is not an actual machine. This is a virtual machine. What does a virtual machine mean? A virtual machine basically means that it is using virtual resources. It is not using real resources. Remember this. Virtual machines resources are also virtual, right? And to handle that, it needs a virtualization platform, right? So not just the VM will be created, there will also be, in extension, a virtualization platform, right? virtualization platform, or you could call it virtualization technology, right? So virtualization technology, there's actually a number of these available. One of the most popular one is KMU, but then you also have, I guess, Hyper-VT or something like that. I don't remember the exact naming, but these are all virtualization technologies which allow you to create virtual machines over real resources. What this virtualization technology does is that it takes the storage and compute of all these machines and it creates a virtual resource out of those, which are the addition of all of these, right? So it sums up all of these. If you sum up all these storages, you have 1.5 TB, right? And your requirement is to store 800 GB, and virtual machine provisioned is 1 TB of storage. So can you store a 800 GB machine now? Yes. Using virtualization technology and using cloud computing, you can actually store this 800 GB file. Virtualization technology, what it will do, it will take your file, it will break it down in parts, and it will store it in some chunks on these machines, right? Say, for example, it's stored 200 or like say 300 GB here, 300 GB here, and 200 GB here, right? But to you, what is visible is not these machines, right? You are not able to see these machines at all. What you are seeing is this machine, right? Which tells you that, hey, you have 1 TB of storage. You can store an 800 GB file, no worries, right? So this is what virtualization technology allows you to do. And when you are doing it over the internet, this becomes a cloud technology. So if you say, for example, for data storage, right? If you have used cloud for data storage, and say you have stored maybe 1 TB of data, it does not mean that Google Cloud has servers with 1 TB of storage on them. No, it does not mean that. Maybe they have all 500 GB storage machines, but they have pooled it together using virtualization technologies, and that is how you are able to get a VM which has 1 TB of storage and which allows you to store that much of data, right? So this is what cloud computing allows you to do, right? This is how it differs from distributed computing, and then this is how it allows you to use pooled resources instead of distributed resources, right? So distributed technology, distributed computing, it is about breaking down a task into several parts and seeing it in that discrete manner, right? But cloud computing, it does not show you the breakdown. It virtualizes the distributed computing, it brings it together, shows you a total big virtual machine, and you can use that for your distributed computing purposes. Worker machine is also connected to GCP virtually. That is not necessary. It could be connected in any manner, right? In ideal cases, they are all situated in the same physical location, and that is called a data center, right? But we all know that it is not possible for all data centers to cater to the entire globe at the same time with the same speed. That is why there are multiple zones defined for a large cloud provider. They have multiple zones defined in which they have data centers all over the world, and whatever resources you want to store or you want to use, they keep it at your nearest data center, which is the standard form accepted, and which actually works. Science allows that. But at the same time, if you want, you could store your files in the US. It will take more time. It will take more transfer cost and things like that. But yeah, they could be connected virtually. They could also be connected physically. Ideally, they are connected physically, but in case of cloud computing, that is not a restriction. They could also be connected virtually over the internet or via private lines provided by GCP. Now, this is actually a major difference between GCP and AWS. AWS traffic goes over the public internet, but for GCP has its own lines all over the world. They have their own fiber cables everywhere, and all the data which is transferred within GCP machines, with GCP's worker machines, they are all happening over private lines, right? So this is actually a major differentiator. If anyone ever asks you about which one is more secure, definitely GCP is more secure because it has private lines compared to public internet used on AWS, right? Cool. So, are we good with this? Everyone understood this? Let me know very quickly in the chat. If you understood this, then we'll move on to the next part of this presentation. Perfect. Perfect. Very nice. Awesome. Let's move on to the next part then. Overview to Google Cloud. And since I explained to you how yeah, there was this. Unfortunately, this session is not going to be about AWS. I'm a cloud GD for Google Cloud, so I am supposed to be talking about Google Cloud, right? So maybe some other day. Yeah. Uh, yeah. That said, what is Google Cloud? Google Cloud is actually, just the extension of what I showed you just now. A lot of worker machines. They have huge data centers, like tens and thousands of data centers, and using those data centers, they provide you pooled resources in many different types, and these are the same data centers which are used by Google to run their own services. Google is the only company in the world, by the way, which has more than 10 products used actively by more than 1 billion people every day, right? So that's a huge amount of network and compute that they utilize every day, and that is why that is such a stable platform. That is, you probably never see Google going out of network, right? Google is always online. People use google.com to check their internet connection, right? It is that reliable. So that same platform, when it is offered to customers in a way that they can use it as a service, that is called Google Cloud Platform, right? And a lot of things are available on Google Cloud in different manners. If you see compute and storage, the most elemental things which I've talked about, compute and storage are the first two services which always need to be considered. Besides that, there's also database, data analytics, networking, AI/ML, and a lot of other services. There's like something around 150, 200 services available on Google Cloud, and you can definitely go ahead and explore them at your own speed. These are some of the most popular services. If you have not heard about them, that is totally fine. But I will strongly suggest that at least these services you get to know about. Probably just Google it, probably go on Wikipedia, read about it. Or if you have access to Google Cloud Console, definitely try using these six products. Compute Engine is in the simplest, the one I showed, the virtual machine, right? So Compute Engine is a virtual machine, bare bones virtual machine. It comes like fresh installed, and you can do anything with it. Right? Kubernetes engine is used for orchestrating containers. Right? So containerization is a technology which is one layer above the virtualization. Um, so within the same VM, you can have multiple isolated containers, and Kubernetes is used to manage containers. Right? So containerization is whole another story, and it is actually the uh, paradigm of modern infrastructure. So something which you might want to study about if you are very interested to go into Google Cloud. But otherwise, you just need to understand that Kubernetes is used to manage containers, and containers are isolated instances of application runtimes. Right. So you could actually Google this, read about it, read some blogs. There's extensive documentation. I'll share at the end of this presentation. I'll share a whole list of resources which you can use to read from, right? So that's it. Cloud functions is probably the most interesting thing which has happened over the years, and it is actually a part of functions as a service. BigQuery is a huge data analysis tool, and you could use BigQuery to run petabytes of queries in seconds. PubSub, PubSub is a very popular service. If you have got Android notifications, if you get all these notifications coming in from say Zomato, Swiggy, or stuff like that, they are all using a form of PubSub, which is basically publishers and subscribers. Zomato is the publisher. Your phone is the subscriber, and whenever Zomato has a new notification to send out, it simply publishes it, and your phone receives it because it's a subscriber, right? These days, if you go on many websites, it asks you, uh, do you want to get our notifications, right? The moment you open the website, there's a pop-up coming on the top which says allow notifications from this website, and you can either yes or no it. If you click on yes, then you become a subscriber to the channel created by that particular website, and that website can then send you instant notifications via PubSub, right? So that's it. Cloud storage, as simple as it comes, for storing things on the cloud. If you have stored data on the cloud, then you are using cloud storage. If you are storing things on your Google Photos, for example, or maybe if you're using Google Drive, then you are in a way using Google Cloud Storage. That is for storing files, and you know it's actually a blob storage, so you could store any kind of file on it, right? Binary, images, text, multimedia, whatever. You could store literally anything on cloud storage. That said, what are the different ways in which people use cloud. On GCP, this is Google Compute Engine, infrastructure as a service, in which nothing is given to you except a fresh virtual machine with a freshly installed operating system. And using that, you could install anything if you want. You can play games on it. That is totally up to you. I'm not sure how many of you have tried this, but if you have a laptop which is, say, 4 GB, it might not be the best machine to play games on. So what you can do is you can actually go to any of the cloud providers. You could spin up a VM with like 90 GB of RAM, and it will not charge you much. It will be like maybe in an hour it will cost you 20 or 30 rupees, and you could install your game there, and you could be connected via a good internet connection. You could play your game on the virtual machine, and after you are done playing, shut it down, kill the VM, and just pay like 20, 30 rupees to do something very resource intensive, right? Just the way I showed you in the example. If you want to do video rendering, if you don't have enough RAM, you give it to your cloud provider, and the cloud provider returns you the data. Game playing can also be done at the same time using infrastructure as a service, because you could install anything, right? You can install a game if you want to. But on platform as a service, which is the other way of using cloud, that cannot be done, right? In platform as a service, you are given an entire platform to use. That platform could include a predefined runtime, and you are supposed to develop products over that runtime. Right? You cannot install your own software. Rather, you are already given existing software. They will install, say, PHP for you, or maybe Python for you, or maybe Java. They will install all these things for you, and then they will tell you that, hey, give me your code. I will run it on my platform, and then your application will be running. But you cannot install your own language. Say, for example, you develop a new programming language. You cannot install that. They do not allow it there. If you want to use your own language, you will have to come to infrastructure as a service. After platform as a service, there's also a very popular one, which is software as a service, in which there's one software which you are given. You do not see the runtime which it is running on, right? You are not told whether it is running on Java or Python or PHP or whatever language. You are not told that. You are said that, hey, this is the software, use it, right? Say, for example, how you use Google Docs, or maybe Google Slides, or Google Meet, right? Google Meet is also using cloud in some manner. Google Docs is also using it. Even Google Drive is using Google Cloud in the backend. But you cannot change those software, right? The software is given to you as it is, and you can use the software. Maybe free, maybe paid, maybe some free, some paid, things like those, right? So all these services which we are using in today's date, say for example, things like IRCTC website, or maybe if you're using even say PhonePe, Paytm, all these softwares, if they're using cloud backend, that is software as a service. And if they are charging you a subscription, then that is definitely a subscription model service. Otherwise, it could also be a freemium service. It could be a freemium uh, or it could be like completely free as well. There are a bunch of services which are like completely free. Say, for example, Google Mail, right? So Gmail is completely free. You have been using it for years without paying anything, but that is also a form of software as a service, right? So yeah, this said, I think I will like to show you an example of how you could build your own software using something which is completely free on Google Cloud, because I understand all of your students, you are more interested in things which are free, and that is why I'm going to explore that, right? So a very easy way to use Google Cloud for free is to use it via something called Firebase, right? So Firebase is a product which is a subset of Google Cloud. There are many services, like as I told you, like almost 200 services on Google Cloud. If you create a subset of them, then you will be getting Firebase, right? So Firebase has a bunch of these services which are provided to you for free. For example, Firebase database, which is either a NoSQL database, or else you could also have connected it to a SQL database, but that is probably going to charge you. The NoSQL database is for free, Cloud Firestore, right? And then it also provides you with hosting. If you want, you can host your applications here. And there's also a real-time database. There's authentication backend. You could use different kinds of authentications if you want to build, say, for example, Google, like log in with Google or maybe log in with Facebook, Apple, whatever you want to, you could very easily build it with Firebase. It also provides you with free machine learning tools. If you want to use some like basic amount of machine learning in your application, you could use it for free via Firebase. Right? There's obviously some limit to how much you can use. If you see, I have been using it for free, and I have not upgraded it, but there's actually a lot of things which are free on Firebase. And if you come to this page, which is like pricing of Firebase, then you will be able to see that a lot of things are for free. Cloud Firestore, 1 GB of storage, and similarly 5 GB of cloud storage is free for you, and 10 GB of hosting is free. Bunch of things are very relaxed, and you could use Firebase to build things for free and use it for a very long time. In fact, I don't think I have ever paid a single dollar to Firebase in, let's say, around 7 or 8 years that I've used Firebase. Cool. This said, there's also other things as well. There's storage, which I showed you. It's like 5 GB of storage for free, and a bunch of other things which I'll let you explore in your own free time. And what I'm going to show you right now is just an example of using Firebase. And for that, I'll show you how it works. Let me go to Firestore database, and at the same time, I'll also open a link which you can open by going to this particular page, or else let me also type the same URL in the chat here, right? So you could also go to poll.xpre.dev, and you will be able to see the application which I'm trying to show you. You could also scan this QR code on your phone if you're using this from your laptop, or otherwise you could also go in your phone as well. And if you do so, then you will be able to see an interface like this. And there's a bunch of these, and none of this will most likely start because pretty much all of them are closed. So what we are going to do, we are going to create something for you right now, right? So what I'm going to do is I'll come here, and I'll click on add document. Let me show you how easy it is, right? So let me say GDSC, Jalpaiguri engineering, yeah, JGEC, I remember, right? So let me say active is Boolean, and it is say false, right? And then I'll have a choices, which will be a map, and it will be choice underscore one. Uh, yeah, actually, let me not create that. It's a lot of work. Rather, I'll show you how this works, right? So active true choices, choice underscore one, name, votes, right? So this is how it looks like. And it's very easy. Okay, so this one is active, right? So let me see if this one is active. Let me actually activate this, right? If right now, if you click on say GCCD Bangalore, then it will not open, right? It will tell you that the poll has not started or it has ended. But if I change this to true, if I change this to true, you do not have to refresh your page. It will automatically start working, right? You don't have to refresh your page. And if you see this, there's a question, and you could actually choose one of the options. And in case you are choosing the options, I'll be able to see live the changes that you are doing, right? Whatever voting you are doing, I'll be able to see it live here, right? So this is actually using Google Cloud. This is using a form of PubSub, and this is completely free. It scales from like 50 users to say 1,000 users without changing a single line of code. Right? This is how powerful cloud can be when you are developing software. Right? Anyway, this said, let me come back to my presentation. Uh, I'll skip some of these slides because I will not go into how we built this. Rather, I'll send you the whole presentation deck so you can build it for yourself. Meanwhile, let's come to what are the tools which you can use to build things quickly on Google Cloud. App Engine, which I'll suggest. If you remember, I showed this to you as platform as a service earlier. I also told you about Cloud Functions, which is functions as a service. Firebase, I showed you just now. Firestore, I showed you just now. Cloud storage, I told you about that. And there's also cloud storage available on Firebase. And then Cloud Vision API is available inside the ML part of Firebase again, right? So in fact, Cloud Functions is also available in Firebase itself. And Cloud Functions is an extension of App Engine. So you have all these services available to you in Firebase. And I'll strongly suggest that you could use Firebase for rapidly building stuff. See, validating ideas should not be costly, right? Uh, Making college projects should not cost you money. So things like these, you don't have to pay for building stuff at introductory level unless you're earning something from your software. Why should you have to pay for it? Right? So this is what Firebase allows you to do. If you're not making money from it, you almost never have to pay for it. Even a lot of people who are earning money from their projects, even they are running in free mode, right? So why not? Cool. This said, here are some tips if you're going to use Google Cloud Platform in future. There's a GCP free tier which gives you a free virtual machine forever. You can use that. There's like 10 GB of free storage. There's bunch of uh, other resources, right? Say for example, um you could use Google Cloud Run for 2 million requests every month. And that is actually a lot of requests, right? So if you're building a college level software, you will never have to pay anything. Trust me on that. It has been like many, many years. I've never paid GCP for anything which I have, just kept in testing. And then there's a lot of GCP pre-built samples which you can try out if you're thinking about what projects to build, how to learn about how to use cloud technologies. There's a lot of pre-built samples. You can go and check them out. And yeah, just say like break down your project into smaller tasks so that you can differentiate which service to use at which place. If you break it down into multiple components, then you will know that, hey, this is a component for which I need Google Cloud Storage. This is a component for which I need, say, ML APIs, right? So start thinking about software like that, and you will be able to do so. This said, let's come to the last part, which is a career in cloud technology. And for me personally, I have only been in cloud domain for like 6, 7 years now. So there are people with like 20, 30 years of experience who have better idea of how cloud has gone from 0 to 100. But at the same time, in the last 6, 7 years, I've seen the boom of cloud, and these are some things which I believe you should do if you are looking for a career in cloud today, right? So first of all, there's actually a huge rising demand for cloud developers, and this is actually very simple to understand why it is happening. There are a lot of people moving into entrepreneurship today, and entrepreneurship demands that software is built very fast. Software, there's this thing called build fast, break fast, right? So this what this means is that you build your software, let it break, and then you keep on improving it, right? But people want to go from idea stage to production to business, right? To earning money. They want to go from idea to earning money very quickly. And that is why using cloud technology makes sense, because cloud technology does not require you to set up your own data centers. You don't have to hire people to manage data centers. You don't have to get professional server grade equipment, which is like you need to have like liquid cooling liquid running through your all your data centers and stuff like that, right? Lots of hassle associated with running a data center. You don't have to do that anymore. It was something which people were doing say 15, 20 years back, but today that is not happening. People are just using cloud for it, and that is why they need developers who understand cloud, right? Developers who can take the entire benefit of cloud, right? At the starting of this session, I told you that whether you are an Android developer or a web developer or does not matter, right? You might be doing machine learning, but if you're able to use cloud in the right way to accelerate your development cycle, then you are always going to be one step ahead of people who only know just Android development or just web development or just machine learning or any of the specific domains, right? So any domain with an understanding of cloud is always going to keep you one step ahead. And that is why cloud technology is something which all developers should understand to use. Uh, and it's actually very broad, right? It's not about just that you only have to know how VMs work, how cloud mesh works, how Kubernetes work. That's not the thing, right? You could know very well Android development, and at the same time you have integrated features of cloud into Android development, and you are good to go, right? But in case you want to get started with Google Cloud today, and you want to understand how to make a career in cloud, not specifically Google Cloud, by the way, this applies to everyone, that you should have an understanding of how cloud platforms work. And I will believe that the things which I explained you today, they will help you in understanding how cloud technology works at the base level, right, at the ground level, how cloud works. I believe you will be able to understand based on what I showed you today. And then you should have some basic programming and Linux skills. A lot of Linux command line is used in cloud computing because uh, see, transferring whole screen is very, very costly, but transferring text is very cheap, right? And that is why text-based terminals are very popular for cloud computing, because transferring text is pretty much dirt cheap. And that is why you are given terminal access instead of a whole screen access, right? You could definitely enable screen access, but terminal access is what is given to all the people who provision a new VM. And that is why you need to have good terminal skills to be able to work with cloud. And then understanding of security on cloud. See, security on your physical device is very different from security on the cloud, right? For your physical device, you can have, let's say, you have put your password and you are pretty much the only person using your laptop. Or maybe if you have siblings or even parents might be using it sometimes. There's probably like 5, 10, maximum 10 people who use your laptop on a regular basis, right? But on cloud, your VM is connected to the internet, and that internet is accessible by, say, 4 billion people, right? These are 4 billion people. Then there are probably 20 billion devices, right? All these devices, all these people, they can all attack your VM at the same time if they wanted to. And that is why understanding of cloud security is very different from how you do security on your like on your physical machine. And you need to understand about this. You need to think in the form of how cloud works. You need to understand what kind of risks and security vulnerabilities can come when your system is running on a 24/7 virtually internet connected mode. Cool. So this said, let me talk to you about something called certifications. Right? Why am I going to talk about certification? I'll also give you a justification for this. Personally, I don't have a certification, but then I am telling you about this. The reason being, uh, see, if you know Android development, you can build apps to show people that you know Android development, right? And if you know web development, you can just build websites and show people that, hey, look, I know web development. This is my website. Just take a look at it. If you know machine learning, you can build machine learning models. You could, show people fancy charts and fancy graphics or text that you have generated using a machine learning model. So these are all technologies which allow you to show your work through samples, right? But how do you show someone that you know cloud? Because cloud is about infrastructure. Cloud is about things which run in the backend, right? Every app on your phone today, every app on your phone is using cloud in some manner or the other. But you don't see the cloud in them, right? You just see the app's interface. You just see the Android app or maybe the iOS app. You don't see the cloud infrastructure on the websites. You don't see the cloud infrastructure. You just see the website, right? So how, as a cloud developer, how are you going to show the world that you actually know about cloud, right? This is where certification comes in, because the certification by a major provider, right? uh, Say for example, Google Cloud has certifications for cloud, AWS has certifications for cloud, and even Azure has, almost all the major cloud providers, they all have certifications. And these certifications are not easy. Not everyone can get them. You will have to go through an exam which is created by these people, and you will have to clear those exams, which are uh, in general decently tough, right? So once you get these certifications, you can, show everyone that, hey, I know cloud, this is the proof, right? So this is how cloud certification works, because you cannot create samples of cloud infrastructure. That is why you need a certification to show people that, hey, I know cloud, this is the proof, right? So it validates your expertise in cloud. And at the same time, cloud certifications are very much valued. right? If you show me a certificate of Android development, I will probably not entertain it. I'll probably say, why are you showing me a certificate of your Android development? Show me the code, show me the app, right? This is what I'll say. Any recruiter will say this, right? If you show them certificates of Android development or maybe web development, pretty much no one is going to care about that. But certifications from, say, Google Cloud, AWS, Azure, or any of the major cloud providers, even Oracle has certifications for cloud. If you show me certifications from these companies that, this is my certification for cloud in these, provided by these companies, then that will be very, very valuable. You can actually check a stat around this. I think the stat is like people who have got certification in cloud from Google Cloud have like 75% of them have got a salary increase in like within 3 to 6 months of getting that certification, right? And it is very, very popular. Everyone knows Google Cloud, everyone knows AWS, everyone knows Azure. That is why you need. No, the certifications are not free. Again, the certifications are not free. They're actually decently priced as well, right? They're probably somewhere around 14, 15,000. And the reason why these are costly is because it discourages people from, applying to these certifications without studying, right? Anyone who is going to spend 14, 15,000 on one certification is for sure going to study a lot, right? No one is going to waste that amount of money. So, because these certifications are very costly, at the same time, they are very valuable and very authentic, they are tough, right? As simple as your college degree, right? You like on an average in India, people spend somewhere around 4 to 5 lakhs in a middle level college to get a degree, right? So once you get that degree, though, it is very much recognized, right? So similar to Google Cloud certification, if you are going to pay that much amount of money, then you better come prepared. If it was cheap, say for example, if it was say 200 rupees or maybe 500 rupees or even free, then a lot of people will be taking these certifications and they might also try cheating, they might come unprepared, they might do it for fun, and this is not how it works, right? It's a proper examination, by the way. There's like when you take this certification, there's a virtual, not actually virtual, there's actually a other person sitting somewhere else who is looking at you via your webcam, and you have to give the exam in such a way that the webcam is placed on your side so that your screen and you are visible all the time. There's no way anyone can cheat in this, and that is why these certifications are costly, but they are very, very valuable and very accepted all over the world, right? So this said, these certifications are not just about cloud. If you have a role, say for example, if you are into Android development or maybe ML, maybe web, you will have cloud certifications for these roles as well. If you are a security practitioner, you will have cloud security certification. If you are a data engineer, you will have data engineer certification. There's also machine learning cloud practitioner, right? So all these different role-based certifications are available, and if you take these, you will actually always stand one step ahead of people who do not have these certifications, right? Um, and then obviously, it enhances your credibility, gives you better prospect for jobs and salary negotiations, definitely. And finally, I think one of the things which I love about this, right? I'll just skip this because if you're interested in getting a certification, do reach out to me. But there's like tons of resources on the internet about how to prepare for these certifications. Rather, what I'm more interested in is sharing with you the idea that you will be a part of a community of exceptionally intelligent people, right? The whole community of people who have certifications in cloud, they are very, very highly trained professionals, and at the same time, people who are very successful in their careers. And once you get to be a part of that community, you will be having access to not just knowledge. At the same time, you will be having access to people who are in a position that they can probably help you get referrals, they can probably help you solve challenges in software development which you might find very tough to scale at the early stage of your career. This said, here are some resources which you can click on to, just find these resources, study through them. I'll very much suggest the GCP YouTube channel and the community tutorials. These are actually very good. Besides that, you could also check out the documentation. Although the documentation is more useful when you are developing software, it's not that useful for just learning purpose. Rather, I'll suggest you go through the GCP community tutorials. Right. So yeah, this was all from my side. Do we have any questions? Yeah.
So if you have any questions, you can put it in the chat.
See, you can ask me questions maybe about cloud, maybe about careers in cloud, or maybe just in general about how cloud technology works. It does not have to be specifically about Google Cloud because trust me, it would make more sense for me to focus on Google Cloud with working professionals than with students. For you, it's way more important that you understand the concept of cloud technology. How can I make a career in cloud? As I said, Anupam, you could either choose to work only on cloud infrastructure, in which you will have to understand how cloud computing actually works, and how to design architectures which are very scalable, which are secure, which can support backends of very popular uh, apps. Right? You could be thinking about, say, 10 million users per day for a starter app. Uh, so you could focus on the infrastructure that will be like pure cloud domain, or else you could mix it with whatever you are interested in, right? Say, for example, you are interested in Android development. You could use Google Cloud for accelerating, say, Android build times. It's actually a very popular use case, right? A lot of people they connect their GitHub repository of Android apps or maybe even web apps. They connect their GitHub repository to Google Cloud so that once you push your code, it goes into build, it goes into preview deployment automatically, and it comes on Play Store very quickly, right? So you could think about that as well. And as I said, right, machine learning uses cloud a lot, right? Pretty much no one in today's date, in their sane mind, tries to do machine learning research and development on their own machine. It's very highly likely that they will simply burn their machine RAMs and stuff like that. So very popular for users with cloud. So depends on what you want to do. Do you want to go into pure cloud? Do you want to go into mixed cloud? Uh, it just totally depends on how you want to do it. You will all obviously, depending on what track you're going into, you will have to study a few different things, and you could just search about that. Actually, if you go to the course curriculum for any of the cloud certifications, they will actually tell you which things you need to study, right? Say, for example, foundational certificates are there. Then, let's say if you want to go machine learning engineer, right? If you want to use machine learning with Google Cloud, then you could just see the course curriculum of ML engineer, right? And yeah, let me show you. Whoop. Yep. Here we go, right? Architecting low-code ML solutions, serve and scale models, monitoring ML solutions, scaling prototypes, and all these ML pipelines and stuff like that, right? These are what you need to learn about. So just, I'm not saying like, get the certification. I'm telling you, go to the certification page, look at the course curriculum, and try to learn these things first. Then you decide of get whether you want a certification or not. That is your choice. But these are very nice places to know about which topics you need to cover. Cool. Any other question? What is DevOps? Yeah, DevOps is actually a paradigm of cloud, pure cloud, right? In which you work with infrastructure management, in which you are primarily concerned with assisting the development team, right? So cloud architect is different. Cloud architect designs the backend, designs the solution. Uh, think about in cloud architecture. Think about this. Let's say you have a let's say you are the founder of Zomato. You are the person responsible for creating the backend of Zomato, right? Now Zomato is used by a lot of people every day, right? A lot of orders are getting placed, huge amount of traffic. So you need to think about what way, in which manner can I arrange my services so that my application does not shut down at any point of time. Think about it like this. Let's say, uh, let's say on weekends, a lot of people place a high number of orders on Zomato, right? Just assuming, just a possibility, just a possibility that on weekends a lot of people place a lot of orders on Zomato, right? On weekdays they do not. If I have a VM which can handle say 10 million orders on a weekend, maybe 100 GB of RAM, right? Maybe 100 GB of RAM. Obviously, that's not going to work, but just giving you a number, 100 GB of RAM, 10 million people. On weekdays, instead of 10 million, only 1 million people place orders. Do I need a 100 GB RAM VM at that point of time? No, because my 100 GB VM handles 10 million people, right? For handling 1 by 10 of that traffic, do I need a 100 GB VM? No, I don't, right? I need to orchestrate this machine's scaling down. I need to reduce the RAM use from 100 to 10. How will I do that, right? And what will be the pattern in which I'll do this? Is there a way in which I could, also have a 100 VM machine, also have a 10 GB VM machine, and then choose between the two depending on which day it is, right? So the whole design of solutions is done by a cloud architect, right? DevOps is much more specific. DevOps is, as I said, it is about assisting the development team. The previous example which I gave, right? If you have an Android source code repository on GitHub or anywhere, and the moment you push to that repository, it automatically goes into deployment. It automatically creates an APK, goes onto Play Store, publishes it, and people get that on their phones that hey, new update is out. This is developer operations, right? So DevOps is actually broken down into developer and operations. A developer does his development work. After that, whatever operations can be automated, that is handled by DevOps. This is very popular with websites. In websites, say for example, you have a Next.js website, right? Maybe React website. So the moment you create the React code, that React code itself is not, it's not possible to run React code directly on the browser. It needs to be compiled, right? You might have heard about Webpack or all this stuff which compile the React code or maybe Angular code or maybe any other JavaScript framework. It compiles that, it creates native vanilla JS and CSS and things like these, and then it publishes those, right? So this could always be automated. You could run a command for this, but that command could be automated, right? Every time you create a push, it needs to build that, it needs to publish that, it needs to probably push it to cloud storage for hosting, it needs to probably push it to Firebase for hosting or anything like that, right? So this is all developer operations, and this is handled by people who do DevOps. Yeah, the way you can get the links in my presentation is, yeah, I'll share the QR code at the end of this presentation. Where I have to start if I want to make a career in cloud technology. Abhidita, as I told you, right, you would choose, you would see the course curriculum from any of the cloud certification, uh, this link. You can click this link, you can choose any of the certifications. You can see what you need to do there. Otherwise, I also have mentioned the very basic topics which you require for uh, essential skills for cloud careers. You can just start Googling these, right? Cloud platforms, Linux, understanding of cloud security. You can just start Googling these terms as well. Key skills include, Linux, DevOps practices, and all that. So you could just start Googling these terms and reading about them. Although I suggest that you probably get access to some cloud provider and start building stuff there. Yes. Why is there an expiration of the certifications in Google Cloud? Yeah. So I think the reason why these certifications expire is because the whole domain of technology, right? If you look at information technology in particular, it is not something in which you can learn things and use it forever for your entire life, right? Say, for example, people who learned Python programming earlier when it was just Python, then it was Python 2, then it became Python 3, right? And so on, the versions kept changing. So people who were an expert at Python 2, they are not necessarily experts at Python 3 as well, right? So this is what happens in the world of information technology specifically. Things change very much, things change very fast. And almost all the software that we use today, they are changing almost overnight. Initially, it was slower, but today it's much more faster. Almost all the software is changing every day. And that is why Google Cloud platform itself, right? When you have 150, 200 services, all these services are changing every day. That is why once you have learned it, you need to get updated on the certification after 2 years. I believe the expiration time is 2 years. You need to renew your certificate, and that is why there's an expiration on Google Cloud. And trust me, it is very rightly so. You cannot, like, think about this. Your professors, right, at your college, your professors studied about website development in a very different manner from what you might be studying, right? In today's world, what we hear is React.js, Flutter, Angular, right? This is the term that we hear today. But when your professors might have done web development, they might have done Java servlet programming, right? JSP pages. They might have done VB.net, things like those, which were popular at that time, probably like 15, 20 years back when people were doing websites. These were the technologies which were very popular, right? But from there to here, everything has changed. And that is why you cannot say that you know web development if you have learned it today and do not study it again for like 10 years, right? In 10 years, web development might be something entirely different. So that is why any technology based certification will always have an expiry. Not just Google Cloud, any of them will have an expiry. Great. So yeah, I hope I answered that. Uh, since I do not see any more questions, I will move forward. And yes, thank you everyone for being an amazing audience. I started with 45 people. I'm still at 42, which is very surprising. Usually, what happens is by the end of 1.5 hour session, the public halves. So kudos to you, all of you, that you did this. And this is how you can get in touch with me if any of you want to get connected. I am not very active on LinkedIn, and most likely I'll not accept friend requests on Facebook. But if you're emailing me your questions, I'll always answer. That is for sure, right? So if you have, like, say, a project you want to discuss, or maybe you have a long query, maybe you just want to talk about career or things like these, put me an email. I always answer there, right? And that said, this is how you can click all the links. Just scan this on your mobile phones or take a screenshot of this, scan it later. Um, you will be able to get the deck which I have presented just now, and you will be able to click on all the links which I showed on my presentation deck. So that was all from my side. I'll give you a few moments to probably screenshot this or maybe take a scan or anything that you like to do. And with that, I'd like to say thank you and Shreya, back to you.
Yeah, so you all can just scan the QR code and you can get the slide deck from there. Also, thank you very much for getting having this session. It was extremely insightful. People learned a lot about cloud as well as cloud computing and careers in cloud.
Thank you,
Everyone
Shreya.
is very happy.
Yeah, it will be amazing if you can, send me what you learned, what if you write blogs, if you write tutorials. Very happy to, get them. If you have a good tutorial, I can help you get it published on the Google Cloud Platform official blog. So you can also think about that. So if you're doing anything, let me know. Great. Yeah, I think I will exit now and I'll leave
Yeah,
the rest
you
of the
can
session to you.
yes, you
Thank
can
you.
just
Bye
wrap up
bye.
the session for now. Thank you. Yes. Bye. Uh, cool. So you all can drop off for the session now. Thank you for being an amazing audience and have a great night.